we go for partial fraction directly following the condition, what we'll get is 2x square minus 3, x square plus 1, x minus 2, x plus 2. It will be ax plus b upon x square plus 1 plus c upon x minus 2 plus d upon x plus 2. This will be the procedure. We have to take the LCM, try to find out the values of the constant. Okay. Earlier method which we learned, that's one method. This is the second method. There's a third method also. Solving this, it might take a lot of time. Here an alternative is possible, so I'm going to explain that method. If that is not possible, you have to go for this procedure. Okay. Now what that alternative method is, what you observe is x square is present uniformly. A point I mentioned in the clues of partial fraction. Now come to that particular point. X square is present uniformly in the numerator and in the denominator. X square term. If I take x square as t, what's the rule for integration? If you take substitution, that means you can't solve the question in terms of that variable. By substituting, you have to change all x in terms of the new variable and then try to simplify. Now here x square is present. If I take that as t, I am supposed to find the derivative of x square. What will the derivative of x square be? 2x. Do we have any extra x, just x present in the question? No, it is not present. So here we are going to use substitution, but we are going to use the substitution outside the integral. Okay. So if you remember, I had mentioned assume x square as t, but do not differentiate. The reason being you don't have an extra x over here to account for the derivative. So you will not find the derivative. You take the expression outside the integral and now assume x square as some other variable. But outside the integral this we are doing because I am not going to find the derivative. For the derivative I don't have an extra x over here. Okay, so write this question in terms of t. So what we have done is this x square we are converting in terms of t, so I have made it a linear term. I will apply partial fraction condition over here now. So what we will get for this is 2t minus 3 upon t plus 1 into t minus 4 equal to a upon t plus 1 plus b upon t minus 4. So I have got two fractions for linear term. I will use normal conditions to find out the values of a and b, but this will be in terms of t. Once you get the value of a and b, before you integrate, normally what we do is we find the values of a and b, we introduce it over there, and after that what we do? Integrate. You will not integrate now. What you will do is you will resubstitute t as what? X square, and then you will integrate. Okay, because this substitution is outside the integral. So before you enter the integral again, resubstitute t as x square, and then you have to integrate. Okay, procedure understood?